Hello guys, welcome back. How's everybody doing? I hope you're liking my videos and having a great time listening to me and learning about Algebra 1. So I just wanted to start with today's topic, which is you know, talking about how's everybody doing. So after today's topic, I'll make like a 10 or 15-minute video after this video, and I'll be talking about there is a quiz I can try to give you guys. So I'll add it in the link of this video. Okay? So just look around for the quiz, and it's on this book. So if you ever want to do extra practice, you can do questions which I don't give you enough time to practice, or which I don't include. So there are extra questions, there are word problems, a lot of different type of questions relating to the lesson that we learn in each video. So if you ever also want to do extra practice, you can look here. So after around 2 or 3 topics in each chapter, there's a mini quiz, and there's also a chapter review and a chapter test after the whole chapter is done. So every time I make a video, so when we finish the chapters, or we come to a point where we need to start reviewing or getting quizzed on some certain topics, from as you can see, from 1.1 to 1.3. So today we're gonna be doing 1.3, and after that I'll add the quiz video with this. Okay, and after that, then we'll be doing 2 more lessons, 1.4 and 1.5, and then I'll add a video in one. I'll make a separate video for the chapter review and the chapter test. So, today's topic is, again, it is actually, I would say 1.1 and 1.2 are the basics of around what 1.3 is. So 1.3 is solving equations with variables on both sides. So let's go with that. So as I was saying, we'll be having 2 lessons combined. So let's just get on with today's lesson, and then you will find this lesson easy if you understand 1.1 and 1.2. Okay. Sorry, just having trouble breathing sometimes. Yeah. So what you will learn today is solving linear equations that have variables on both sides, and identifying special solutions of linear equations. Okay? Oops. I don't want to show the solution to example 1 though. Okay. So solving equations with variables on both sides. Okay? So the core concept for that is to solve an equation with variables on both sides, you have to simplify one or both sides of the equation if necessary, and then use inverse operations to collect the variables terms on one. Sorry, excuse me. To collect the variable terms on one side, and collect the constant terms on the other side, and isolate the variable. So what that means is, so for example, so as it says, solve an equation with variable on both sides, simplify one or both sides of the equation if necessary. So if I have something like 10 plus 5x, and that equals to, for example, 3x. Let's do something like 16. I don't know, I just picked a random number. Alright, so it says then use inverse operation to collect the variable terms on one side, collect the constant terms on the other side, and isolate the variable. So what that means is, what we've been talking about the past 2 videos is that we were given an example like 10 plus 5x equals, let's just go with 5. Alright, and then we would do minus 10 on both sides, minus 10 on both sides. That will lead to 5x equals -5, and x equals to -1. That was what we have worked or accomplished or developed as a skill from the last two videos. But we're not gonna be. We're actually. I'm sorry. We're not. Just like excluding that. We're actually adding those skills. So like, you're using this skill in order to solve this question right here. Alright? Let me just erase that. You're doing this skill right here in order to solve this one right here. Okay? So let me just go ahead and erase this and we can get on with this. This is not like a question in the book. I'm just trying to show what the core concept is trying to explain. So this is actually a question related to this topic, so I just gave you an early head start. Okay, so yeah, it's fun. Okay, so when it says to use inverse operations to collect the variable terms on one side and collect the constant terms on the other side and isolate the variable, well, we know what 1/3 of that question means. Actually, 2/3, or maybe 3/3, or one. You know what all those terms mean. Constant is what we talked about in the first or second lesson, which is just like a regular number 10, for example, in this equation. Okay? A variable term is something like 5x. That's an example. Or even 3x. And for constant, again, it would be 16. Okay? So those are constant and variable terms. And isolating the variable, well, we have talked about. Move the variables on one side, move the constants on one side. Well, the core concept is just trying to explain that, but it's just saying in a proper detailed explanation. So if I were to isolate the variables, if I were to move the variable terms on one side and the constant terms on the other side, what would my equation look like? Well, since I have gone through this, like these lessons a lot, okay, for me, I would do something like, um, this and then in the same step. But since you guys are still learning on remembering to subtract or add or multiply or even divide on both sides, we're just going to go step by step. It's okay if it takes a long time. I want you to understand the concept of each lesson, what I'm trying to explain. Alright? So you understand the fundamentals, the basics, and then use those skills to solve the actual hard problems. Okay, so for example, if you want to make this whole equation like positive, what I mean is like positive as a variable term and positive as a constant term, what would you do? Well, the first step you can do is do minus 3x on both sides, because what you get on both sides is going to be a positive, right? You're going to get 5 minus 3 equals 2x, and 3 minus 3 equals 0. Okay? So you're just going to have it like that. Okay? So what you're going to have now is 10 plus 5 minus 3 is 2, so 2x equals 16. Now look at that. We have got this part. We have actually done this part. I just showed you an example, like not even like 2 minutes before, on something that was like 10 plus 5x minus 5, right? It was something like that, right? So this is what we're doing again. This is just what we practiced in the last two lessons, and you're implementing that. So this is basically just doing an extra step or not doing an extra step. Okay? So what I mean by that is, if you want to do an extra step, that means doing 5x minus 3x. If you just want to write it out, then it's 10 plus 2x equals 16. Okay? I mean, I'm not like connecting back. I'm kind of like connecting back to the problem. I'm like, if I were to write this equation, how would I look at it as? Would I just say, I just want to write, for example, 10 plus 2x equals 16? Or would I say something like 10 plus 5x equals 3x plus 16, and then I would solve it from there instead of just doing 10 plus 2x equals 16. So in one of them, you're not having one extra step. In one of them, you're having an extra step. Okay? So with this, now what do we? It's like a normal thing. We're just isolating the variable. That's what I've been using that word a lot. Well, the meaning of that is just leaving the x alone or leaving the variable terms alone to give the x a value. So that would be, to do that, I would be doing negative 10 on both sides, or I would say minus 10 on both sides, not negative 10. This would come out to 0, so it would just be 2x equals 6. And then, like always, divided by 2, divided by 2. X equals 3. Also, you might have noticed I'm not doing like addition property of equality or subtraction property of equality. You might notice I'm not saying those words because now at this point it should be in your head by now that I don't need to remind you. Okay? I'm not being mean or rude, but it's just that we need it's now like a time to like remember those things, Because if you don't remember what each of those properties of equality does, then you won't be able to solve these questions correctly because your equations won't match on both sides. And if your equations don't match on both sides, then your answer comes wrong. Alright, now what we're gonna do is now we're actually gonna solve a problem. Alright, so you know what? Should I erase this? I'll just leave it alone. I'm just gonna make a line. Okay, so now we begin with our actual lesson. So our first example says, solve 10 minus 4x equals negative 9x. Okay. So I'm just gonna take a snap of that with my snipping tool. I'm just gonna, I don't care about the check your solution. It's okay. We all can know how to check. Okay. Now, to make this bigger. Okay, you know what? I think that's a little too big. Oh, okay, yeah, that looks better. So it says 10 minus 4x equals negative 9x. I just went to the smaller size for the pen because it takes up too much space with that red one. It's like a big marker. It's like a bolded marker. So, yeah. So, now what we're going to do is we're just going to solve it like a normal thing. So what you want to do in this one is, again, isolate the variables. Okay? So some people in this case will actually do this. I'm just going to like fast forward it or like show it to you. Some people would do this. I'm going to tell you this. And then they get into negative 4x equals negative 9x minus 10 plus 9x on both sides plus 9x on both sides, 5x equals negative 10. People would do that. I mean, I've done it a lot of times because it's easier for me. Because people feel that, oh, x should always just be a positive value. Well, in this case, you're going to still have the same value even if you do that. Okay? Even if I do it the way I just showed it to you, or if I show you the way I'm going to show it to you like right now, both of them are going to give the same x value. It's just that one step, you do an extra step of moving both of them. You'll see what I mean. You also saw like what I did. So you'll see what I also mean right now. Okay? This is just like a normal question that we've done in the past 2 lessons. Alright? So what you want to do in this one first is isolate the variable. So you want to have a constant term equal to a variable term. Okay? So what you're going to do for that is, well, we're going to do plus 4x and plus 4x on both sides. Okay? That's a bad line, but it's okay. And that will give out to negative 5x okay, x will equal to what? -2. Okay? It's just one step lesser. Okay? If I were to do the step I showed you, again, I'm just explaining it, that would be something like I have, so I'll just write out the question again. 10 minus 4x equals -9x. What I would love to do is that people tend to say, oh, the variable term should be or like a positive value because it's easier for your brain to function like that, right? Even mine was. But then I understood if I don't do that, or if I just don't waste my time doing that, I can actually solve this question pretty faster. Okay? So I'm just gonna show you what I did before I solved it the way I want you to try to solve before. Okay? The actual way, there's no correct way to solve. People can do the shorter way or the faster way and get the same answer as people doing the longer way and the slower way. Okay? So that's just what I want to explain. Oh, sorry for erasing that. But in this step, what we were going to do was we were going to make our variable term positive. Well, if I want to do that, I would say -10 on both sides first because I want to just leave -4x alone, right? Right? That's my goal. Or something, part of your goal, actually. So that would be -4x equals -9x minus 10. Well, you can't divide -4 on both sides and give it an x value. You can't do that because there is a -9x in that too on the other side as a variable term. Well, remember how we talked about last class of combining like terms? That's just doing that. So combining like terms is related to this. So, regarding that, what you will do now is isolate the variable one more time. Or actually now uh, you'd be isolating the constant term technically. And now you'd be doing 9x, positive 9x on both sides. So that would be 5x equals -10. Well, x is still going to equal to -2. So these two scenarios equal to each other, okay? Those two equal to each other. But this one is shorter and this one's longer. Okay? In the first one, we just did plus 4x on both sides. We isolated the variable and the constant to equal to each other, and then we just found the x value. In the longer one, we did minus a -10 on both sides. Okay? Then we said -4x equals -9x minus 10. Then we positive 9 on both sides. And then we made our variable term constant. Sorry, I keep saying constant. Sorry. We made our variable term positive. So, it gives you the same answer. It's just that one step can maybe make your mind a little more confusing or easier to understand. So it's up to you. If you want to have a negative variable term, you can have it. If you want to have a positive variable term, you can have it. In some scenarios, you'll even see that having a positive variable term is more easier to solve than a negative variable term. So in some cases, you'll be lucky because you'll be able to find the positive term, positive variable term faster. So now we're gonna move on to the other question. Now this is solving an equation with grouping symbols. Okay. Now example 2, I'm just gonna take a snip. I know you see the answer, but I'm gonna still show it to you anyways. Okay. So in this one you have 3x in minus 4 in parentheses equals 1/4 and 32x plus 56 in parentheses. Okay? Now, with that, what you want to do in this first part is simplify all of these. Always simplify. Always get to the basics. Always make the equation write out in a way that you understand and you can process it and then you can solve it. I'm emphasizing on the you because it is important that you understand that equation and you solve it correctly to get the values correct or to get the actual answer correct. Me. Okay, so in this first step, what you want to do is, well, in parentheses, okay, parentheses, and then there's a number outside, okay? And there's something in the parentheses, well, it's distributed property. You just multiply that outside number to each of the values inside. So if I do 3 times 3x, that would be 9x. 3 times negative 4, do not forget the sign, okay? People sometimes forget the sign, and they say, and then they get the answer wrong, okay? So 3 times negative 4 is minus 12, or actually negative 12. And then you have 1 over 4 times 32x. Well, in that case, it's going to be like 1 over 4 times 32x over 1. Well, that equals 32x over 4. And that just gives you 32 over 4 equals 8, and then put the x. So that equals 8x. So 1 over 4 times 32x equals 8x. If I do the same for positive 56 using the same method, I'm actually just going to get 14. No. Is it? I forgot. it's going to be 14. I know that for sure. Yes, it's 14. Yes. Now, look at that. Look at that. Doesn't that remind you of a question that I showed in the beginning? Yes, it does. Here's that question. See, you're just adding more steps and then coming back to the same point. You add more steps to your questions, you add the difficulty to your questions, you bring it down to the simple parts of the question that you are able to process and solve it, and then you just solve it. So, what you now do is minus 8x on both sides, minus 8x on both sides. Okay? You get 9 minus 8 is x, minus 12 equals 14. Now look at that. That part is equal to something like this. Now, that's referring to something that we did in the first two lessons, not lessons, but first two lessons. Now, what you want to do is plus 12 on both sides, plus 12 on both sides, and then x will equal to 26. So, your x value is equal to 26. That's how you solving an equation with grouping symbols. Okay, now moving on to example 3. Okay, I actually today want to skip the monitoring progress because I want to give you guys more homework or like extra practice questions. Okay, and they're gonna be a little harder, so that's why I wanted to give you more. Okay, now sorry. Just, I don't know. I was trying to show you your homework. Alright. Now, we're going to solve example 3. Sorry. Excuse me. Example 3, part 1. I just closed it. Oh my god. Caramba. That's what I would say sometimes. just move this. Let me copy paste. Ooh. That's I think that's big enough. Okay. So in this one, you see a grouping symbol again, or distributed property. So let me just write out the question. Equals 15x. Okay. So in this one, you again multiply the outside number to the numbers or the values inside the parentheses. Oh, my chair's about to fall. But let me just fix that. Okay. So 3 times 5x is actually 15x. Not actually, it is. And 3 times positive 2 is 6. Equal to 15x. So x, now I do negative 15 on both sides. Negative 15x on both sides. And then I get 0x. Yeah, sorry. Oh wait, I actually did it wrong. Wait, it's gonna be 0x over here and 6 over here. I should have actually started from here because I want to put it on this side. Okay, equals 6. Well, you really can't say 0x because you don't know. You just can't say it's 0x because you don't have a value of x. Okay. So that is saying 6 equals 0. Well, I'm really actually sorry, but I forgot to explain the core concept about this. I'm so sorry. But, like, going back to the core concept of these two problems that we're going to do actually, is saying special solutions of linear equations. Equations do not always have one solution. An equation that is true for all values of the variable is an identity and has infinitely many solutions. An equation that is not true for any value of the variable has no solution. Okay? So, in this case, you see that 6 is equal to 0. Well, 6 is not equal to 0. 6 is only equal to 6, or 6 times 1, or anything like that equals to actually 6. So you know that's wrong. So in this case, you'll just put the answer as no sol, or actually write it as a no solution. I'm going to tell you, some teachers will accept no sol. Like my teacher sometimes accepted no sol. But I was like that time, like he told us, like my teacher told us that if I put like no sol on like a test or a quiz, he would accept it. But he always also said that you always just remember that to write no solution outside like the full thing is better because that shows that you really know what it means. And it also shows like what the what like not just like what it means, but it's more like that the answer that you're saying is more written out in detail. No sol can just mean like anything. No sol, no sol. I mean, I keep saying it, but it's better if you write no solution because then you'll also understand what you're trying to say or what you're trying to write as the answer, and the teacher will also understand. So I would recommend always writing out no solution if your answer is actually no solution instead of writing no sol. Okay? So that's my actual, it's a good tip. Always don't forget to do that. Now going back to our second question, that is negative 2y negative 2 times 4y plus 1 equals negative 8y minus 2. Now, you see that negative 2, see something in the parentheses, always distribute. That's your first thing. So you're going to do negative 2 times 4y, which is negative 8y. And you're going to do negative 2 times positive 1, which is negative 2 still, because the signs are not the same when multiplying, so the signs are going to be negative always. Equals negative 8y minus 2. Okay? Now, in this case, I'm going to do 8y on both sides, 8y on both sides. Got that as 0. Minus 2 equals 0 minus 2. So minus 2 equals minus 2. Anytime you have something like this or this or even this as an answer or a part, you know that if something like this is equal to this in like an answer like this, I know I'm using a this a lot, but you'll know what I mean. This means infinitely that's spelled right. Infinitely. Let me check if I even spelled it right. Nope, I didn't. I knew it was an I between that. Yeah, I knew that was an I. Totally knew. Infinitely many solutions. Okay? That's gonna mean that no matter every time you put a value, you're gonna get the same value, no matter what. If I put 1 in this side and 1 in this side, you're gonna get the same outcome. It's gonna be something like whatever answer you get on this side, for example, whatever value you get on this side is gonna be equal to whatever value on this side. So that's actually today's video, or technically lesson. Okay, so now this is your homework. Solving from 3 to 16. Okay, it's only 14 problems, I'd say. 14 problems. So I want you to take a screenshot or even a picture of this, and let me just make it like, yeah. Let me just make it the center. So that's her whole thing. And yep, so that's today's video. It's about solving. Let me even check. I forgot what it is, but it's, oh my god. It is solving equations with variables on both sides. So I hope you guys liked the lesson today. Okay. Keep watching my videos about Algebra 1. We are gonna I think 2 videos, we're gonna start our our new chapter. So let's go. It's gonna be official 5 lessons for the first chapter. So make sure you keep watching my videos and learn about Algebra 1. And I hope to see you again. And I hope new people come and join too. So thank you once again and have a great day. Have a great time. See you. Peace out. And remember, my name's Ayaan. Okay? Have a great day. Peace out. See you. I hope you guys have fun learning with me. And remember, my name is Ayaan and I'm from KARMANT Learning. And yeah, please keep liking and subscribe to the videos.